Since the earliest days of the space program, astronauts have been trying to find a way to control their movements in the weightlessness of space. Training in the empty cargo bays of C-135 transports, the astronauts first experienced the strange sensations of zero gravity. The Gemini program saw astronaut Ed White become the first American to walk in space, maneuvering himself with a device called a zip gun. Soon after, Dave Scott crawled along the outside of his spacecraft using grab rings and metal handholds. But not until the Skylab missions of the early 70s did the astronauts test devices which would not only maneuver in space, but do so without a tether. NASA and Martin Marietta experimented with a number of prototypes, the most successful of which were the astronaut maneuvering units. Finally, in the spring of 1984, astronaut Bruce McCandless gently rose, untethered, from Challenger's payload bay into the vast expanse of space. The maiden voyage of the Manned Maneuvering Unit, the MMU, had begun.
Well, that may have been one small step for Neil, but it's a heck of a big leap for me.
Roger, copy that, Bruce.
For the first time in history, a man was flying in space, alone and untethered, in full control of his movements, traveling over 17,000 miles an hour. 150 miles above the Earth.
We sure have a nice flying machine here.
Roger, it's a great team effort.
Powered by 24 nitrogen jet thrusters, the MMU is a self-propelled backpack that gets an astronaut and his tools quickly and efficiently from one place to another. On the simulator at Martin Marietta's Denver Space Center, the astronauts mastered the MMU in less than 18 hours. To fly, an astronaut uses hand controls mounted on his armrests. The left hand determines speed and direction, while the right hand determines attitude, or in pilot's terms, pitch, yaw, and roll.
That looks real smooth, Bruce. Just like you're on that simulator up there in Denver. Hey, I can see stars out here.
Perhaps the most ingenious feature of the MMU is attitude hold, a mechanism that allows an astronaut to select a position and automatically maintain that position without any additional commands. This enables an astronaut to approach a work site from any direction he chooses, select a position, punch the attitude hold button, and remain in place, free to work. Equipped with an MMU, an astronaut literally becomes a human spaceship, with his eyes as his optics, his hands as his manipulators, and his brain as his computer. NASA Space Station Project Manager, Clark Covington.
It's actually a spacecraft, the way I look at it. The spacesuit and the MMU together make about as small a spacecraft as you could ever devise. But it's got all the life support systems, communication system, propulsion systems, attitude control systems, everything that a spacecraft would have, and it makes a one-man spacecraft.
Okay, well, that's a good scan of it. Challenger Houston, the President of the United States.
Let me ask you, what's it like to work out there unattached to the shuttle and maneuvering freely in space?
Well, we've had a great deal of training, sir, so it feels quite comfortable. The view is simply spectacular and panoramic, and we believe that maneuvering units, first time working unattached, we're literally opening a new frontier in what man can do in space, and we'll be paving the way for many important operations on the coming space station, sir.
By the early 1990s, there will never be a day without a man in space. Permanent space stations will revolve around the Earth. Orbital transfer vehicles will shuttle men and material to and from geosynchronous orbit. And on board, the MMU will be standard equipment.
You have a go. Okay, I get my last little pitch maneuver out of the way here. Have a good one, mate. Thanks, Alex. You needed that. There you go. 1 potato, 2 potato.
Martin Marietta MMU manager Bill Bolendonk.
We really have now a new device which becomes a part of our bag of tricks to be able to perform. The ability to do work in space requires that we have a man and his complement of tools. The MMU now is in that complement of tools. So it's really up to the design community as to how they're going to use the MMU.
The MMU will allow astronauts to function like construction workers, retrieving and repairing satellites, assisting in the deployment of huge solar arrays and antennas, and assembling the modules that make up space stations. The MMU was designed to complement, not compete, with robots and other automated systems. The on-orbit assembly of space stations and other space architecture will be accomplished with a complement of tools, including remote manipulating systems and orbital maneuvering vehicles, as well as MMUs. On Earth, men and machines work together. The same will hold true in space. For many dangerous or repetitive tasks, robots are preferable to humans. Yet when circumstances change the nature of a task and a job requires the presence of an active intelligence, there is still no substitute for a human being. Since the dawn of civilization, man has explored the unknown, discovered new worlds, and established settlements in hostile environments. Yet in the last 25 years, we have traveled further than we ever dreamed possible. Space is the new frontier. Where once we were explorers, now we are settlers. Once again, we are on the threshold of an old and a new world. Leonardo da Vinci said, "Man is the measure of all things." The success of the MMU is a reflection of Martin Marietta's commitment to this ideal and to the permanent presence of man in space. The triumph of the MMU is the most recent reflection of what we have always believed. The only limits are those of imagination.